Hey everyone, welcome back to MLWorks. In this video, we'll learn how to scale machine learning model with FastAPI, Docker, and Kubernetes. In the previous video, we built or trained a machine learning model and served it using FastAPI endpoint. In this video, we'll take that forward and containerize that FastAPI application and deploy it in Kubernetes cluster. To complete this task, you have to install Docker in your machine, and you also have to install Minikube. So I'll be sharing the video for Minikube. I'll be putting that in the description and you can check that out. And to complete this task, first you have to create a Docker file, and then you have to build a Docker image from the Docker file and save that to the remote registry. And once that is done, you can spin up your Minikube cluster, and then you can deploy your deployment/service YAML and run your pods and services in Kubernetes. So we'll come back to this diagram when we are talking about Kubernetes cluster. First, what we'll do is we'll just overview the code that we have written for model and FastAPI application. For model, first we trained the model with the help of logistic regression, and we trained it on iris dataset, and we created a model like this, iris_model.pickle file. Once that is done, then we moved on to main.py, where we have our FastAPI application. So first we import all the necessary packages, and then we create a class for validating the input request that is coming in with the help of Pydantic, and then we do create a lifespan method which will act as a startup and shutdown for the FastAPI. And when you start up the FastAPI app, you want to make sure you load the model. Loading logic is written here, and once we have done with the lifespan function, we go ahead and create the app where we map our lifespan function. And once you create this instance, this will be executed, this function will be executed, and your model will be loaded. So once that is done, then we create our API endpoint /predictor. So what will happen is, once you send a request, it will contain 4 features, and that will be validated with iris features class. And if it is correct, then we'll go ahead and predict it. So for prediction also, we need to format it into array or list of list. So we do that here, and then we go ahead and predict and get the response. So if you want to deep dive into these 2 files, you can go and watch the previous video, and we'll now go ahead and deploy the application in Docker and then move on to the cluster. Now let's talk about Docker file, which is present here. To create this Docker file, first we load the base image where we have Python 3.11 installed. So from this image, we'll be setting the working directory inside that image, which is working directory /app. Inside this directory, we'll have our application code. So if you see here, once we set the working directory inside the Docker image, we copy the contents of our application. For instance, we pass the requirements.txt and to the current directory position, which is /app. And then we install the packages inside the Docker image. And then what we do is we move our model file, and then we move our FastAPI application to the current directory, which is the /app. So we expose 8000 port inside the Docker image, and then we run our uvcon server, which is the final command when you're trying to run the Docker image. This will be the final command that will be executed. So here you will have uvcon server, and this is the file name, and this is the app instance of the FastAPI. And this is the host information, and this is the port number on which the app is running. So this is with respect to the Docker file. Now what we'll do is we'll create our Docker image. So I'll go to the terminal, I'll clear this up. Now if you see here, this is the folder where my Docker file is present. So I'll go and build docker build tag command. This is FastAPI ML, and then what we do is we load it from the current directory, the Docker file. So this will build my Docker image, and once this is built, we'll push this into remote repository. So here, this is my Docker file, not Docker file, Docker image, Now what I'll do is I'll go here in the next terminal. I'll do docker login. So here it will, since this is already stored, the authentication information is already stored, it directly succeeds in logging in. If you are doing it for the first time, you have to do docker login, give the username for your Docker Hub and the password for your Docker Hub, and then it will log in into your Docker Hub instance in the backend. So now it's already logged in. So what I'll do is, first I'll take this image, which is FastAPI-ML. I'll tag that into my remote repository. So docker tag FastAPI-ML, which is my latest Docker image, and the source or the destination is this one, Mayur28. This is the username. If you see here, this is the username. This is where I want to push my Docker image. So FastAPI-ML : 0.1 version. So this is done. Now I have to just push this image. So this will push my Docker image, which is FastAPI-ML 0.1v, into my Docker Hub repository. You can go ahead and check it here. I'll go into new window, Docker Hub. I'll just log in here. So it is mounting the image. You will see it here. Let me refresh this one. So So what was the name? FastAPI-ML. Let me refresh again. So FastAPI-ML is present, which was less than 1 minute ago was pushed, and this is the tag that I used. So my image is present inside the Docker Hub repository. Now I can use that Docker image inside my Kubernetes deployment YAML. So let's move towards deployment YAML now. So but before we do that, let me start the Minikube server. So clear this Minikube start. So this will spin up my Kubernetes cluster in the backend. So while this is happening, let's go to deployment YAML. So this is our deployment YAML. So there are only two things to remember here. So one is deployment, the other is service. So let's understand with the help of this diagram, which is present here. So the way it communicates, so finally the user will be outside. Okay, he won't have access to the pod or the service that is running inside the cluster. So what we have to do is we have to provide access. So to do that, what we have to do is first we'll create deployment YAML, which will contain all our FastAPI application. So currently we have one container, which is one Docker image, which is one pod. Now if you want to handle multiple requests simultaneously, or if you have high traffic, then you have to run multiple instances of the application. So what we do is we create replicas. So we create 3 replicas, and then that is deployed as a deployment inside Kubernetes. Now that will be running on port number 8000, which is the port which was suggested or used by FastAPI for running the application. Now that will be exposed as part of your container. And then what we do is we connect that deployment to the service, and that service will be connected to the user or will be accessible by the user. So the user will hit service will be providing access to the pods. So when you have multiple requests coming in, so service has the ability to send the traffic or load balance the traffic between the pods, such that one of the pod is not overloaded with the high number of requests. So that's the flow that is happening here. So we'll see it here in the deployment YAML. In deployment YAML, you will see we have first this is the deployment name. This is the deployment name, and this is the app name that we are giving, which is FastAPI-ML API predictor. Now this label, this is coming under label, and label will be used to map your service to the deployment. So if you see here, when you are going to the service, you will see there is a selector. So you will map this FastAPI-ML API predictor, which is mapped to this one, this label. So these two are connected with the help of this label. And under specs, the key point is we have our replicas, which is 3. And so there will be 3 instances of your container running. And we specify the container information here. And then we have our resource details here. So what is the image that we created? Let me go back here. So this is FastAPI -ML. So I'll go here, FastAPI. So let me remove this. FastAPI -ML, and then this is 0.1 V, I guess. Yes. So this is where we mentioned all the details related to the container and what is the resource that is required for running that specific image and how we are going to expose that container, which is 8000. So if you go back here, right, the deployment, it will be exposed on 8000. So each of the pods are exposed to 8000 port. And then that 8000 is connected to the service. So if you go back to service now, this is one of the resources in Kubernetes, and this is used for networking. The key purpose is to ensure there is a persistent IP address, because what happens is sometimes due to some issues, random issues like resource issues, there is a chance that one of the pod might fail and the IP address, and it restarts and it creates a new pod. So when a new pod is created, a new IP address is assigned. So there is too much of dynamic changes in terms of IP address. So we create a service which will have a persistent IP address. With the help of that, you will be communicating to the pods. Now coming back, so here we connect to the deployment, and then we expose our service with the help of port 80, and the protocol we are using is TCP, and here the type is node port. So since I am running my local machine, I am sending the node port. I am using node port because I want to expose the app that is running inside the cluster to the node that is my local machine. But if you don't want to expose your service outside, you can put cluster IP. So that will be only accessible inside the cluster. Then if you are using something called as like cloud service provider like GCP or AWS, then you can use load balancer. Now coming back to this replica, we have set it as 3, which is primarily for handling multiple requests simultaneously. But there is in production setting, normally what happens is we don't set it as some static value like 3. What we do is we create something called as horizontal pod autoscaler, where we keep min-max replicas. So when the traffic is low, we just want one replica to run. As the traffic increases and the CPU utilization increases beyond like 50%, you can start increasing the replica to 5. So this is how you will slowly scale down your application. So this is with respect to scaling and high availability for your application. Now what we'll do is, since we have mapped our Docker image, now what we'll do is we'll run this YAML file. So I'll go here to the terminal, and if I just do kubectl, so if you see, right, minikube start is done. It is up and running now. Now we can do get pods to see what are the pods that are running. So nothing is running already with respect to the FastAPI. So what I'll do is kubectl apply -f. I'll give the deployment YAML. So now it has created the deployment and the service. Now you can go ahead and check get pods. You will see 3 containers getting created 7 seconds ago. Now let's go and see get deployment. So you will see FastAPI ML AI API deployment. Now we can go ahead and see the service, get service. So you will see here FastAPI ML API service. So everything is up and running. Now what we want to do is we want to expose our application that is running inside the cluster to the outside world. So what we can do is we can get the IP address. So for that, what we have to do is minikube service, and can give the service name I think this should work, and get the URL. So let us see if it brings up the URL. So yeah, service not available, no pod running for. Okay, so let us see, get service. So we have it running, get pods. So yeah, there is some issue with the image. So let us check what is the issue. kubectl logs. So let me copy this. I think there is some issue with respect to the image. So let me go here. This is FastAPI-ML 0.1v. So this is correct. So I think maybe this is where things are going wrong. So what I'll do here, right? I'll just modify this one predictor to there is other way to debug this one. So let me resolve this issue and come back to understand the issue more. So what we do is we do kubectl describe pod and pass the pod name, and we see that it is taking an older image which is not present. So what we have to do is we can modify the deployment YAML. So what I'll do here is I'll just go here and modify this one YAML, and then this I'll remove it here, and let us see, this should update everything in the backend. So this is done. Now what we'll do is save this and trigger this again, not this one. We'll apply the file again. Now let us see, kubectl get pods. So now this is done. This is the previous run. Now it is creating, container is getting created in the backend. So let's wait for this. So it should not throw an error. So kubectl get service, it should create that service, which is this one. So let's wait for the pod to up and run. Okay, so here if you see, it is up and running. So it has managed to download the specific image, and we are able to will be able to run now. So before we do that, let me see, right, if I can go and get the YAML for this one. So I'll take this pod name and get pod -o YAML. So here you will see, yeah, this is the updated image. Okay, so it is not referencing to the older image. Now we have our updated image. Now what we have to do is we have to get the access to that service, because if you go back here, we want access to the service such that we can able to access it from external browser. So what I'll do here is, first I'll do clear this one, minikube service, and then what was the service name? Let me go here, get the service name. If I go here, there will be MLAPI service. It's the name of the service, and then I'll get the -- URL. So this will give me the IP address and the port on which that FastAPI application is running. So I'll copy this now, and I'll go to the browser, hit this one with docs, and it will show me that iris classification. Here I can go and test it out. So just do some random testing and execute it, see the response. Yes, it's working fine. Now one thing to understand is the reason why we have kubectl get pods. So the reason why we have 3 deployments running is because if you have higher traffic coming in, then you can pass your traffic towards any of these pods such that you can handle the request. If you have only one pod running, then your request will be queued, and there is a very tendency, there will be an expiry time after which the request will be dropped. So better to have multiple replicas, keep it up and running, and such that you can handle higher number of requests in parallel. So what we have seen is we have created an ML model, then we used FastAPI to expose that as an FastAPI application, and then we use the Docker file to create a Docker image. Then we push that to remote repository. Then we updated the YAML file here, which contains both deployment and service. Deployment is where you will pass your container details and the resources required, and then we have a service that will communicate between user and the deployment. So with that, I'll be concluding this video. I hope you understood how to scale a machine learning model with FastAPI, Docker, and Kubernetes. Thank you for watching.